We have already seen that the random forest, we have already seen the random forest that is built by using simple the base learners as the decision trees, plus we have doing the row sampling, plus we have doing the column sampling, and after that we are edge based models, we are taking its aggregations. That's the job we have to do to build a random forest. Now just discuss case by case what is the in various cases what is the random forest behave. So already in decision, in the series of decision trees we have seen in the various cases of the decision tree. Now since the decision tree is a base learner models in the random forest, so it is much more similar to the decision trees cases, but there have only two differences in bias variance trade-off and in the place of features importance. So let's see one by one. So the just if you remember the decision tree, so this thing is very useful. Decision tree is very useful for a low dimensional data sets. So the large dimensional data sets decision tree cannot handle so much. So large, if we have a large dimension of data, so decision tree cannot work proper well. Large dimensions of data. Okay. Now another thing, the main failure of the decision tree is if we have a categorical features with many categories. Okay, if you have a very categorical features with many categories in such scenario, also the decision tree may not work very well. Categorical features with many categories. With many categories. In such scenario, also decision tree fail. So this is the failure cases. Now let's see. Now let's discuss one by one each cases. Okay, first discuss bias variance trade-off of a random tree. Bias variance trade-off of a decision tree. So let's first discuss this. Sorry, it will be for a random forest. Okay. So for a random forest, we have learned the bias variance in random forest is depending on the its k value, its number of base learners value. Okay, number of base learners. Its performance depends on the k. Number of base learners. Okay, and this thing and the thing in the and if you just remember the decision tree, and if you remember the decision tree, so the performance of the decision tree is dependent on its depth. Okay, this thing. But the random forest, is built as the base learners of decision tree. Here base learners is a decision tree. Here base learners is decision tree. And we already seen that, and we have already seen that the bias variance for random forest, we are taken the decision tree as the as a as possible, as a possible depth, means as a maximum depth, because of reduced its variances. We have already seen this thing. For a random forest, the base learner decision tree, we are typically taking its depth 10 to 20 or its maximum depth, because our sample data set to our original data set is large. So, and if here we are using the aggregation technique for edge based learners model, So by simple using these things, we are easily reduces these variances. Okay, because of that the depth is not matter for here, but the number of base learners is matter. If we increase the number of base learners in our random forest, that's mean what? That means the base that's mean if we increase the number of base learners, that means our sample size is much more smaller. If our sample size, if data sample is smaller, that means our base learner model, age based learner models, depth of the age based learner model is lower, means it's also is smaller. Because of that reasons, we can easily handle this variance problem. Okay, already one of our lectures already we have seen this thing. Now the second thing is that the features importance. Features importance. So in the decision tree, if you just recap the decision tree, in decision tree, the features importance means, decision tree means what? Decision tree is like look like that. This is one nodes, this is one nodes, this is one nodes. Look like that. This is one nodes. This is simple the decision tree. And here in edge nodes, we have used here the some checking conditions, if else conditions, some checking conditions. Suppose let's take we are using the features. Suppose let's take we have a features fi that is used here in this node, and the same features also used this here, this node fi. Okay, so if you just taken the features fi, that means overall reductions for these features fi, overall reductions in the entropy or gain impurity because of these features at various levels of this. So we are just using the overall reductions of the entropy, how much reductions of entropy is reduces. So for each features, according to these results, we have decided which features is best of us. So the overall reduction, so the overall reductions in for these features, if we just consider the one features, if I overall reductions in entropy or gain impurity, overall reductions of the entropy, that's depends because because what? Because or the features of various levels of the, suppose here if I is use this level, so because overall reductions, because so these features, depends on various levels, of the decision. I think the features importance, one of our previous lectures we have already covered the features importance of the decision tree. So the overall reductions of the entropy or gain impurities depends on the importance of the features. But the random forest, by example, if you the random forest are built by using such k decision tree, this thing is work for single decision tree. But the random forest is work for or a k number of decision tree, k number of decision tree, k number of decision trees. Suppose let's take this number is, suppose let's take m1, m2, mk, k number of decision tree. The overall reductions of the, so the overall reductions, so here it is the main important. So the overall reductions of the entropy, that is H, or the Guinea impurity Ig, of the impurity, because what, because here we are using because of at various level, MIs. Okay, this is the thing. The features importance here, this for a decision tree, the features importance used only for its its overall reductions and of entropy or Guinea impurity in a single decision tree. But since random forest is built by using a sets of decision tree, a collections, a number of decision trees, okay, because of its features of a random forest, it depends on the age reductions of the impurity, reductions of the entropy or Guinea impurity for age models. For age, it depends on the for age MIs. Okay, that's things depend on a single decision tree. That's thing for random forest. That thing depend on the all the decision trees. Because suppose in a column sample, what actually we have been doing. So in column sampling, we are in column sample. This is the suppose our main data sets DN. Okay, and here we are built sampling. Here also D2 by using the some sampling. Here we have using the DK, we have using some sampling. So here we have this column sampling plus as well row sampling. Here also, so suppose let's take in this column, here we are using this column F1, F3, F, suppose let's take, suppose we have, let's take 10 features, we have F3, F9. Here we have using F2, F4, F8. Here we are using F6, F9, F10. So this thing. So here in this decision tree, the features are depends on the, suppose if you just think one I'm writing here decision tree, one more decision, F1, F4, F9. So see this thing. So F1 features are depends on how this decision to D1. Suppose this thing, F1 features depends on D1 decision tree and also D3 decision tree. Okay, so this thing, the combinations of the D1, the combinations of the entropy for features 1 as well as combinations of the entropy for features F1 or D3. So the entropy is organic impurity or features 1, for features 1, it's depend on the D1 and D3. Similarly, F9, if you just see this thing, F9, F9, it depends on the D1, D3. If you just see this thing, F4, it's depend on the D2, the D3, like that. So overall the entropy, overall the reductions of the entropy, It depends for the features f9, if for the features f1, I think it will be okay, the thing, okay. So the overall reductions of the entropy, it's depend on the, for features 1, it's depend on the decision tree D1 and also decision tree D3. So this is the simple main thing. This is the simple main thing in the state of using single decision tree. For a random forest, we have to consider the set of decision tree to find the best feature according to the reductions of the entropy.